In this video, I'll be showing you how you can use energy bar graphs in 3 different example situations. So first, we will look at A. So, not looking at those two, looking at just the first one there. So there is no friction, it is not moving at C, and it started at A. Well, if we have, which kinds of energy do we have? Kinetic, gravitational, spring or elastic, and thermal. So kinetic, gravitational, thermal, there's no friction. Since there is no friction involved, thermal energy we don't need to worry about. Elastic potential energy, there's no spring. So we don't need to worry about that either. At all 3 positions, the only thing we're going to have is either kinetic or gravitational potential energy. So gravitational potential energy, let's see, up here, we know it's not moving, there's no kinetic, so that means all of the energy is gravitational. So position A, position B, position C, if I make energy 0 at the bottom, I'm going to define the bottom here as being the height 0. So gravitational potential energy won't be negative. So I'll put 0 at the bottom. It's all gravitational potential energy at C. At A, it's at the bottom, so there's no gravitational potential energy. That means, at that point, it's all kinetic. And at B, it's between the other two. How high is it? Let's see, it's about that high above A. And it's basically the same height difference between B and C as it was between A and B. So we're about halfway up the hill. That means there's half as much gravitational potential energy. So it's about half UG and half K. So that's A. Let's try B. So now, looking at B. Again, no friction, so there's no thermal energy to worry about. There's no spring, so there's no elastic potential to worry about. We only have gravitational and kinetic. So it starts here, and we'll call this, since that's the lowest level, we'll call that y equals 0. And so if y equals 0 here, that means gravitational potential is 0 at the beginning. So it's all kinetic. So initially, it's all kinetic. Then here, it's gravitational. Definitely we have gravitational because it's up higher. But it doesn't stop here. Look, it keeps going and gets over here to C. So that means it must still have some kinetic energy here at point B. We don't know how much because we aren't given information about what the actual speed is, but we know there's some there. So I've chosen to give it mostly gravitational and some kinetic. Then down here, you see it ends a little bit higher. So, I don't know, maybe a third as high as B was. So however much gravitational we had before, now we only have about 1/3 that much. So I know they're all the same height. We have a little bit of gravitational and a lot of kinetic at the 3rd position. All right, so that's the second one. Now let's look at C. All right, in C there is friction and the car is stopped at point C. So this one looks just like this one, except that the car is no longer moving here. All right, so position A, B, C. We have the same amount of energy every time. At C, there's no kinetic, there's no elastic. We have thermal and we have gravitational. So it looks just like B, except instead of kinetic here, it's thermal. Position B, if there's friction along the whole track, then there's already some thermal energy here. There's still some kinetic because it gets across, and there's gravitational. So there's gravitational, some thermal, and some kinetic. At the beginning, no gravitational because it's at the bottom. No thermal because we're just starting. So normally we will start with 0 thermal energy, and then if there's friction, thermal energy will increase. If you start with thermal energy here, you'll have to just add that same thermal energy in all the way across. It's easier to set it as 0 at the beginning. So that is for C.